number 62, sample of 4 milliliters of diethyl ether. That's C2H5O, which actually comes out to be C4H10O. Has a density of blah, blah, blah. Is introduced into a 5-liter vessel that already contains a mixture of N2 and O2, whose partial pressure is blah, 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 blah. Okay, so temperature held at 35 degrees Celsius. So first thing we need to do is find, if we're eventually going to use P of diethyl ether, okay, CH10O times the volume is going to equal N of dimethyl ether, RT. So we're going to find this, which means all of this over V, and I can get rid of that. But to be able to find this, though, I need to find N. So how do we find N? That's really the question. N is the number of moles. So how do we find number of moles? Well, we're given information that's very close to finding moles. We're given density, we're given volume, and we have to find the mass. So that's what we're looking for. 4.0 milliliters. Density is 0.7134, and that's grams per milliliter. So when I solve for, I do my little density triangle. I've done this all the time. I have mass on top, density and volume on the bottom. When I cover up mass, because that's what I'm looking for, I get density times volume. So literally mass equals density times volume, which equals 0.7134 times 4 milliliters, like that. And whatever that equals, I'm going to squeeze it in down here because we have a lot of calculations to do for this. Whatever that equals is going to be my mass. Now once I have my mass, and I'm going to keep all the digits here, I'm going to change my mass to number of moles. So that's going to take up the rest of this. I'm going to have to do B in a different color because I'm going to bleed into where B is. Doesn't matter, don't worry about it. So I'm going to do 2.8536 like this, that's grams of dimethyl ether over 1 times, and then I'm going to, for 1 mole of dimethyl ether, which is C4H10O, I need to find the number of grams per mole. Now you've done this before. Carbon, hydrogen, oxygen. I have 4, 10, and 1. Times 12 is 48, times 1 is 10, and times 16 is 16. And I add all of these up here. These numbers that I'm getting here is the atomic mass on any periodic table. It should be 12.0, 1.0, and 16.0. And the numbers in front here are the subscripts. So these are subscripts there. So C4H10O1, because I add these up, 2 plus 2 gives me 4, 5 plus 5 gives me 10, and of course there's a 1 there. So all I do is add these up to get 74 grams per mole, like that. And now I take my 2.8536 divided by 74, and this gives me the number of moles. Now the whole reason why we did this was so that we could find N for PV equals nRT. I should run this out a couple of places, just simply because I don't want this to be the thing that limits the factor. Yeah, okay. So once I have the number of moles, now I can continue on and do my pressure equals, and then I have 0.0385620 moles times R, which is going to be 821, then times my temperature. Now my temperature is just plus 273, so 35 plus 273 is what looks like 306 Kelvin. I have to change it to 306 Kelvin because we need Kelvin for the ideal gas law, and the whole thing is a 5-liter vessel, which is my V. So now I do this, what I'm doing is typing in the R value times the number of moles times 306 Kelvin equals, and then divide by 5, and that's going to give me a pressure of C4H10O of 0.194 atmospheres. And that is of C4H10O, like that. Okay, now I'm going to do this next part here. It couldn't be easier in the fact that Dalton's law of partial pressure is very simply the total pressure equals the pressure of the gas of N2, the pressure of the gas of O2, plus the pressure of the gas of C4H10O, like that. So I just simply add them all together. So what are all the pressures here? Let me see what they are. They are 0.751 atmospheres plus 0.208 atmospheres plus 0.194 atmospheres. So I just simply now add these all together. And what I get then, to answer B, is 1.153 atmospheres. I could probably round off to 3 significant figures. 1.15 for my total. That's the total for number 62. Okay, I don't think there's a B. I think that's it. So I move on to 66, and it says, well, the mole fractions of each of the components of the mixture of 5.08 grams of O2, 7.17 grams of N2, and 1.32 grams of H2. Well, okay, the mole fractions means I'm going to, for each one of these, like for O2, I'm going to take 5.08 grams, I'm going to divide it by, 16. What I mean is 32 because of that right there. 32 grams per mole is going to give me, divided by 32, equals this number of moles. I'm going to carry this out and round off at the end. That's the number of moles of O2. I do the same thing for N2. 7.17 divided by, now because of that N2, it's 14 times 2 is 28, 0 grams, so 7.17 divided by 28 equals, and I get 0.2561 for this one, and my last one is for H2, and that is 1.32 grams divided by 2.0 grams per mole. Okay, these are all numbers off the periodic table. This is 16 times 2 because 16 grams per mole for one oxygen, but since we have 2 of them, 14 times 2 for 28 to get 28 grams. So this last one is 1.32 divided by 2 equals 0.66, and that is also moles of H2. Now I simply add them all up. Once I add all 3 of these up, I get a total of 1.07485. That's total moles of mixture. And now for each one of these, I do 0.15875 divided by the total, 1.07485, and I'm going to round off to 3 places because that's what it has for each one of these. And that gives me my mole fraction of 0.148 for oxygen. That's a mole fraction. It does not have units because it's moles over moles. Let me do the next one. 0.2561 divided by 1.07485 equals this mole fraction here is going to be 0.0238 for N2, And the last one then is going to be 0.66 divided by 1.07485. Like that is going to be 0.614 for H2. Those are the mole fractions for all of them. What is the partial pressure in atmospheres of each component of this mixture held at 12.4 liters vessel at 15 degrees Celsius? So all I need to do now is find pressure. PV equals nRT for the total. Okay, I have the total number of moles. That's what this number is right there. So what I do is solve for P. So P total equals N total times R times T divided by V. I just simply fill in what I have. I have 1.074, I could just do 75. Like that. That's the number of moles. My R value I'm going to use for atmospheres. And then my amount is 15 degrees Celsius plus 273. What I do every time is to change to Kelvin. And that will be, what, 288? 288 Kelvin, like that. And the whole thing is divided by a 12.40 liters. Okay, whatever that pressure is now going to be times 0.0821 times 288 equals that divided by 12.4. And that's going to be my number of, that's my total pressure. Let's just round that off to 5, because that gets messy. That's my number of atmospheres. Each one of these then is going to be times 2.05 atmospheres equals the partial pressure. So this times 0.614 for hydrogen is a partial pressure of 1.26 atmospheres of H2. This one is going to be 0.238 times 2.05 equals, this right here, by the way, is P total. So mole fraction times the total pressure will get me the pressure of each one individually. Of N2, and then finally the last one equals, that says atmospheres, whatever, 0.148 times 2.05 equals there. So now I have the number of atmospheres of each one. So that actually is B. I'm going to stop there because I think this took long enough, and I'll put a part 2 up then.